In this problem, Althea has two different investments that she's considering with her $5,000. One is 4% investment compounded monthly, and the second one is 4.2% compounded annually. So for the first choice, since I have monthly compounding, I need to use P plus 1 plus R over N to the NT. So plugging in those values, I am going to call this function A of T because it's my first one. 5,000 is my principal. My rate is 4%, so I'm using 0.04, which is that number as a decimal. And it's monthly, so that means the number of times per year is 12. The n value also goes in the exponent, and then I'm going to leave the t for this general function. So this is my first function. My second function, I notice it's compounded annually, so I could use the compound interest formula, but compounded annually basically means once a year, so I can also use the basic formula, which is what I'm going to do here. So that's P times 1 plus R to the t. So I'm actually going to call this function B of t to differentiate it from the first choice. So my P value is still 5,000. My R value is now 4.2%, so that's 0.042, and then to the t. The next question asks me which of these options will yield more money after 5 years. So I'm going to pause the video and just write down both of the formulas with the 5 plugged in, as well as their answers. So here are my two functions with 5 plugged in. I see that B of t just barely beats A of t, so I would write option 2, and I could also write 4.2% compounded annually. So even though we know that compounding more often can make more interest grow because there's more chances for that interest to grow on the newer amounts of money that are added, that 0.2% still made B of t win for this particular situation. The third part of this question asks us to algebraically determine how long it will take for the money to double under the 4% option to the nearest tenth of the year. So I'm going to take A of t and set it equal to 10,000 because that would be double the original amount. Now, I know I'm going to have to work with logarithms in this problem, so one of the first things I'm going to do is rewrite this base as a decimal. That's not going to be, I'm not going to be able to write down the whole decimal because it is a repeating decimal once I write it down, but that will at least help with the problem. At the same time, I'm also going to divide by 5,000, which is my first algebraic step. So I get 2 equals, and then this decimal is 1.003. Once again, I'm keeping that whole decimal in my calculator, and that is raised to the 12t. So now that I am in Ben form, where I have a base, an exponent, and a number, I will write this as a logarithm. So log base 1.003 of 2 equals 12t. My last step is to divide by 12, and I get that my t value is 17.4 to the nearest tenth years. Now, if you typed in 1.003 for the log, your answer might be slightly off. Remember to keep that whole decimal that you found when you originally typed in the base of this function.